This is Gabriel Galarza, and I am doing my grade replacement question for test 1, and this is question 375 about implicit differentiation. And here I'll be expressing dy over dx in terms of x and y. So to start with this equation, we have to derive each individually. So we would start off by getting 4x to the third, which is derivative of x to the 4, and then we have 4x to the third times y, which is we have to use the product rule. So to do product rule, we go ahead and put the derivative, the first term, times the derivative of the second term, which is y, where the derivative of y would be 1. So because it's y, we're getting the derivative of dy over dx, so we're going to go ahead and put dy over dx here. And then using product rule, we're adding, so then we'd get the derivative of 4x to the third, which is 12x squared, times the next term, which is y. And then we'd go ahead and get the derivative of y to the fourth, which is 4y to the third times dy of dx. And then the derivative of 1 over here would be 0. Then what we would do is we'd have to find like terms in this problem. So we go ahead and group the like terms in here. So we'd go ahead and put 4x to the third plus 12x squared to the y here, because we have 4x to the third dy dx plus 4y to the third of dy dx. So once we get that far, we're going to go ahead and equals 0. So once we do that, we want to go ahead and try to find out how to get dy over dx by itself. So we go ahead and subtract out this entire problem, and we would go ahead and get 4x to the third dy dx plus 4y to the third dy dx equaling negative 4 to the third plus, negative 4 third plus 12x squared to the y. And then what we would have to do is, here we want to go ahead and group get this dy dx out. So in grouping this, we would go ahead and get dy over dx times 4x to the third plus 4y to the third equaling negative 4x to the third plus 12xy squared. And by doing this, we go ahead and divide out 4x to the third plus 4y to the third. It cancels out, and we bring it over here. 4x third plus 4y to the third. And then we go ahead and simplify each one of these out. So by simplifying, we go ahead and get negative 4x squared times x plus 12y over 4x squared plus 4y squared. And by doing this, we can easily, this is all equal to dy dx. And by doing this, we can go ahead and simplify out these this 4, and then we'll go ahead and get negative x squared times x plus 3y. Oh, I'm sorry, made a mistake up here. When I brought out this 4, I went ahead and changed this to a 3. So yeah. So yep, by bringing out the x's, I go ahead and get this, boom, and then this would go ahead and change down to x cubed plus y cubed, and that is how you find dy over dx with implicit differentiation.